Hello friends, welcome to our YouTube channel. Now in today's class we will discuss about the Young's double slit experiment and the fringe width determined by this experiment. Okay, or analytical treatment for the fringe width. So first of all we will see the Young's double slit experiment. So for that observe this diagram. Here the scientist Young, he shows that whenever a source of light it is divided through two slits in two different sources and then interference pattern if we carried out, we will get such type of interference bands on the screen. Okay, so here observe that a single source S, from here the ray of light it is moving in the forward direction, means wavefront these are moving in the forward direction. Then a slit S1, through the slit S1 it is made into a narrow beam. So from there the wavefront these are shown, spherical wavefront are formed there. Spherical wavefront are shown there. These are moving in the forward direction. So in front of that we are keeping the double slit, means two openings in the slit. So what it will do, due to this the two sources, coherent sources will form here. We are dividing the light into two parts. So here the same source is there, hence two coherent sources will form as S1 and S2 on the slit S1 and 2. Okay. इंटरफरन्स पॅटर्नसाठी आपल्याला कोहेरंट सोर्सेसची गरज आहे. कोहेरंट सोर्सेस जर एका सोर्सपासून तयार केले असेल तर कंपल्सरी आपल्याला कोहेरंट सोर्सेस मिळणार आहेत. सो हा कन्सेप्ट यूज करून एका सोर्सला त्याने डिवाइड केले. स्लिटने S1 आणि S2 दोन सोर्सेस आपल्याला इथं फॉर्म. नाउ हियर from S1 and S2 we are getting here, according to Huygens principle, two different sources and secondary wavefront will move forward in the forward direction. Okay, so here observe that from source S1 the waves these are moving in the forward direction, and similarly from the source S2 also these are moving. Now here the alternate crust and trough are shown by two different colors, means the dark color and the white color. Okay, so when these are intersect with each other, or if they interfere with each other, we will obtain on the screen the pattern of alternate dark and bright bands. This pattern on the screen is nothing but the interference pattern of the light. Okay, now here observe this diagram. When crust will match with the crust of the another wave, S1 and S2 two sources are there. If crust of the source S1 it is matched with the crust of the source S2, then we are getting the bright point. Similarly for the trough, trough matches with trough, we are also again getting the bright point. Okay, so when we are getting the similar overlapping, here it is the constructive interference, we already know that. Okay, so due to constructive interference amplitude will increase and we get here brightness. So all such cases here are shown as a bright bands. And when crust of one is matches with the trough of another, here the destructive interference takes place and we are getting the dark bands on the screen. This pattern is called as a interference pattern, and this experiment carried out by Young. This is the first successful experiment to show the interference phenomenon. Before that there is no success to carry out the interference. Okay, now let us find the difference between the two consecutive dark fringes and the bright fringes. That bands here, alternate bands, these are called as a fringes, and the distance between two consecutive bands is called as a fringe width or band width. So let's find the expression for this fringe width. Okay, now see, suppose we are having two sources S1, S2. The distance between two sources here it is represented as small d. The screen it is placed from a distance capital D from the slits. Okay, and we are getting their alternate bright and dark fringes on the screen. Now let the point O it is situated exactly at the center of that screen. That means the center point it is, if we consider the bright, then the central bright fringe, the point O it is situated. Now in this condition, the path difference means what? From slit S1 to the distance up to O, and from slit S to the distance up to O. So this difference between two path is called as a path difference. So in this case, path difference S2O minus S1O, it is 0, because both waves travel same distances from S1 S2 to O. Okay. Now let this point is situated arbitrary on any fringe. So let here this point P, it is situated above this central bright ring. Okay. Now here the distance of the source S2P, and distance from the source S1, it is S1P. The other are same. Now here what is the path difference? Path difference, it is always the integral multiple of the wavelength, that means n lambda. So here we are getting the path difference for this condition, it is S2P minus S1P is equals to n into lambda. Now the distance of that point P from the center, it is x. Okay. So observe this diagram carefully. From the center the distance is x. Distance between two fringes, two slits, small d, and slit and screen distance, it is capital D. Okay. So now let's start with the x. Now first concentrate on one triangle, that is the triangle S2RP. Okay. So from this triangle we can find the Pythagoras theorem, or we can apply Pythagoras theorem in this triangle. It is a right angle triangle. So here we are getting that S2P square is equals to S2R square plus RP square. Okay. So according to the diagram, S2R is nothing but the slit and the screen distance, capital D, and RP, it is nothing but the point P to the lower of the that S2, means x the distance center पासून वरती आहे आणि उरलेला half distance, that is the half of the slit width, that means d by 2, means here RP is nothing but the x plus d by 2. So substitute these values in the above expression, Pythagoras expression. We will get here S2P square is equals to d square plus in the bracket x plus d by 2 whole square. Okay. Now see the second triangle. From triangle S2QP. Now observe this is also a right angle triangle. So again apply the Pythagoras theorem. So according to Pythagoras theorem, here S1P square is equals to S1Q square plus PQ square. Now again observe the diagram. The distances of these terms are from the diagram. Okay, so PQ is equals to, now PQ, it is upper portion, so we have to subtract the d by 2 from the x, so it is x minus d by 2. And next it is the S1Q, it is equals to the d, capital D, that is similar screen distance from the slit. Okay, so substitute this value in the Pythagoras equation. We are getting here S1P whole square is equals to d square plus in the bracket x minus d by 2 whole square. Okay, so let this will be the equation number 2. So we are subtracting the second equation from the first equation. So S2P whole square minus S1P whole square. Okay, this is the LHS subtracted with the LHS. To the RHS, what we are getting here? For the first equation, we are getting here d square plus x minus d by 2 whole square in the one bracket minus second bracket d square minus x minus d by 2 whole square. Okay, so here these two different terms we have to subtract. Now open the bracket and try to solve this. After solving this, RHS we are getting only 2x into small d, 2xt. Okay, so here we are getting that 2xt. Now LHS, it is the a square minus b square formula. So S2P minus S1P and S2P plus S1P. This is the LHS by the formula a square minus b square is equals to 2x into d. Now find here path difference काढायचा आपल्याला. path difference काय असतो s2p minus s1p. So here we are getting s2p minus s1p is equals to the second bracket we are shifting to the RHS. 2xd divided by s2p minus plus s2p plus s1p. Okay. So now consider a condition that the slit they are very close to each other, means the distance between s1 and s2 that is very small, and in compare to that the distance of the screen from the slit means capital D, it is very large, means small d is less than the capital D. So in this condition the s1p is nearly equal to the s2p. तो पॉइंट पी जो आहे तो खाली सरकलेला असणार ह्या कंडिशन मध्ये, आणि असं जर केस असेल तर दोन्हीचा जो डिस्टन्स आहे हा नियरली इक्वल राहतो. सो फॉर दिस कंडिशन in the RHS denominator both will be the same, that is nothing but the capital D. Okay, so S1p plus S2p म्हणजे capital D plus capital D, it is 2D RHS मध्ये. Okay, so here we are getting path difference, we already know that it is n lambda. So n lambda is equals to 2xd small d divided by 2 capital D. Okay, now 2 to get cancelled, here we are getting that n lambda is equals to xd divided by d. If we are going to find the fringe width, so if we are going to find the value of x, what is the value of x, then from this formula just cross multiplication, n into lambda capital D by small d. So this expression represents the distance of the fringes or the fringe width for the any arbitrary point P. Now we will find the fringe width for the successive bands, that means the particular fringe width between two successive bright and dark bands. So for that first we consider that for the bright. So if we are considering the nth band, then this formula can be written as xn is equals to n into lambda d by small d. And for the next successive, the number n will change to n plus 1. So xn plus 1 is equals to n plus 1 lambda d by d. Now subtract these two equations, means the distance between x nth and n plus 1. That means successive चा आपल्याला डिस्टन्स मिळेल. हा जर nth असेल तर त्याच्या नेक्स्ट वाला n plus 1 असणार आहे. ह्या दोघांचा मधला डिस्टन्स काय झाला, फ्रिंज विड्थ झाली. सो दॅट डिफरन्स वी आर गोइंग टू फाइंड हियर. सो दोन्ही इक्वेशन सबस्ट्रॅक्ट करायचे. आफ्टर सबस्ट्रॅक्टिंग वी विल गेट हियर द आन्सर ॲज अ लॅम्बडा डी बाय डी ओनली, मीन्स fringe width for two successive bright fringes, these are lambda d by d. Okay, similarly if we find for the dark fringes or dark bands, then here fringe width it is represented as beta. So for that again we observe that we are getting the same lambda d by d expression for the bright also, dark also, means two successive dark fringes or two successive bright fringes, they are equally spaced in the interference pattern. Okay, so this beta, it is nothing but the beta is equals to lambda d by d. Okay, now discuss about the intensities. If I1 and I2 are the intensities of the individual sources from the slits S1 and S2, means here we are getting the two sources S1 S2. If I1 and I2 represents the different intensities, then we know the resultant intensity, how we can represent it. IR is equals to I1 plus I2 plus 2 square root of I1 I2 into cos of phi, where phi represents the path difference between two interfering waves. Phi phase difference. Okay, so this is the formula for the resultant intensity. Now we are using in the Young's experiment the same source is divided into two sources, coherent source form करण्यासाठी. So here intensity will remain same. So I1 is equals to I2. if we substitute this here, the equation will convert as IR is equals to 2I किंवा I नॉट दाखवू आपण, एकच इंटेन्सिटी आहे, वी आर रिप्रेझेंटेड हिअर विथ द I नॉट. सो IR इज इक्वल्स टू 2I नॉट प्लस 2 स्क्वेअर रूटमध्ये I नॉट स्क्वेअर आल्यामुळे तो पण बाहेर येणार, 2I नॉट cos phi. Now see in this term 2I naught cos phi, 2I naught can be taken as a common. So in the bracket we get here 1 plus cos phi, and from the trigonometry identity we know that 1 plus cos phi, it is nothing but the 2 cos square phi by 2. Okay, so we use here this concept and we are getting the final answer as IR, resultant intensity will be 4I naught cos square phi by 2. Okay, after solution of this we are getting here that IR is equals to 4I naught cos square phi by 2. Now for constructive interference we will find this. Okay, so for constructive interference the phase difference, it is represented as 2n pi, means the positive or even multiple of the pi, 2n pi. So if we substitute this value in the above equation, we will get for constructive interference IR is equals to 4 into I naught. Okay, so this is the simple expression for this intensity, 4 into I naught for the IR, constructive interference. Okay, now for the destructive interference, the expression we have to use that phase difference for this, it is given as 2n plus 1 into pi, odd multiple of the pi. Okay, 2n plus 1 into pi. So if we substitute that 2n plus 1 into pi in the expression, we will observe that the resultant intensity, it is found to be 0. Okay, so for the destructive interference, the resultant intensity, it is 0. Hence we are getting the dark fringes or dark band. Okay, so this is the total expression for this Young's experiment. The experiment is explained here. Later on we discuss analytical treatment for finding the fringe width and the intensity expression for constructive and destructive interference. Hope you understand all this. If you have any doubt regarding this point, comment here, like our videos, share it and subscribe.